Hello, and welcome to
Small Talk about the Big Issue.
I'm Lorraine.
And I'm Kiara.
And in this podcast, we discuss the big issue that is climate change in a way that's accessible and hopefully enjoyable for you to learn about.
Mm-hmm.
That being said, I found it quite hard, Kiara, to introduce today's topic.
Yeah.
Because I think the science behind it is quite sobering.
Yes.
And I'd like to say that while the science isn't good news, it's good news that we're making this podcast, that there are people out there listening, that the first step to tackling this big issue is to understand what's going on.
Yeah.
And that does mean being confronted with facts that are perhaps alarming.
Yeah. The only way to solve a problem is to know it very well, to know it from different angles, and to confront yourself with the uncomfortable truth. So this is what we're doing in this episode called Who's Going to Pay the Price? But Lorraine is right to warn you that it might seem a bit depressing, but that is the situation, and we want to spread nothing but scientific facts and the truth.
Mm-hmm. And there are, intergovernmental, governmental, community level, and individual level solutions and actions we can take that we will discuss in other episodes. But yes, this is the episode where we kind of face the facts, I think, in a lot of ways.
And we're ready.
Yes, because I think the answer to who's going to pay the price is quite simple, really. We're going to pay the price.
Mm-hmm.
We're all going to pay the price.
All of us. Animals, humans, no one's going to be spared.
Yes. And understanding that, I think, is the first step towards taking action. Climate change and global warming are going to impact not just the temperatures we experience, but also what the landscape around us might look like, the food and the water that's available to us, the diseases we might encounter, where we're able to live.
Mm-hmm.
And so what we'd like to do in this second episode is to build on the first, where Kiara had given an overview of what global warming is, how it works, and what I'd like to do in the first part of this episode is to explain how that might translate into climate change.
Okay.
And what phenomena that involves and how they might impact us.
And I'll follow up with an article about a very specific example of an ecosystem that is impacted by global warming and climate change, and how this impacts both the wildlife that relies on it and us humans.
I'm really excited for this article. It seems very interesting. I would like to dive right in to the first part by discussing a figure that really struck me during my research for this episode. I have to say, I spent a lot of time on the IPCC. The IPCC we mentioned in the first episode is the Intergovernmental Panel for Climate Change. And it's a consortium of scientists who get together, and they don't produce science, but they produce a report that summarizes existing science every 7 to 8 years.
And they not only do they produce 1,000 pages of reports, they also produce summaries for policymakers. It's a condensed version of the text which is made available to policymakers all around the world, and which, if any of you are interested, it is a lot easier to read, I find.
Yes. I read the technical summary, which is not the long report, but the very condensed, perhaps slightly more technical version of the report. Now, I had attended talks at university about the IPCC. I had watched people relate their experiences about going to the IPCC. I had never actually read the report. And so it was really interesting for me to read. And there's a figure that really struck me because I think it illustrates the point that we're trying to make with this episode of the podcast. And the figure I'm talking about, if you'd like to, look it up, is figure 3 in the technical summary of the latest assessment report, the 6th assessment report.
Could you describe it for those who don't have it in front of their eyes?
Yes, I will describe it. The figure is kind of like a table. So you've got the first row that's observed impacts of climate change on human systems.
Okay.
And you've got 3 broad categories. You've got water scarcity and food production, health and well-being, and impact on cities.
Okay.
And then the first column is all the continents.
Okay.
And within every box in the table, you've got either a plus or a minus, depending on whether climate change has been shown to impact that region and that specific area of human society.
Those different categories, health, well-being.
Yes.
if this is being impacted positively or negatively by climate change in those different areas.
Yes.
Okay.
And in a glance, by looking at this figure, you're able to see that the effects are overwhelmingly negative.
Wow.
There's almost only negative signs in that table, which means that across all human systems and across all continents, climate change is affecting all of us detrimentally in different categories of life.
Whether it be food availability or the infrastructures we use.
Exactly. And so for me, this figure was quite striking because really you see in one look that climate change is a global issue and that there's nothing to gain from it. It's exclusively something that's going to be detrimental to us. Now, the first part I'll be discussing is split into two smaller parts. One is, how does global warming translate to climate change and what phenomena does it involve? And then the second is how these phenomena will impact human society.
I think we're all very eager to know.
But I'd like to start off by saying I haven't made an exhaustive list. I don't think there's an exhaustive list that we have at the minute. So this is going to be maybe a whistle-stop tour of what climate change means for us. And I think the first way that global warming leads to climate change is through disturbed weather patterns. And I'll just discuss just two mechanisms. One, which I'll get back to later because I think it explains a lot of the natural disasters we're seeing, is that warmer air can hold more moisture. So for every degree that the thermometer rises, you're getting 7% more moisture in the air, potentially.
And it doesn't seem that much now when you say it like that, 7%, what is it? But bear in mind...
I thought it was quite a bit.
Bear in mind in the last episode that we said that water vapor is one of the most potent and most important greenhouse gases. Although it doesn't stay that long in our atmosphere, it's responsible for a lot of it. So more water vapor in the atmosphere activates some sort of crazy positive feedback loop where more vapor induces more warming, which in turn increases water vapor in the atmosphere through evaporation.
Yes, and even more directly than that, it can lead to some pretty torrential rain and downfall and precipitation, which I'll get back to.
Okay.
The other way warming can disturb weather patterns is through the modification of what's called the jet stream. There's a polar jet stream that is a fast-moving wind that flows over the Arctic. And as the Arctic warms, that jet stream also warms, and that changes the way it flows. And so it brings patterns of weather, not just in the Arctic, but worldwide, that we can't necessarily predict and that aren't the ones that we are perhaps used to.
Okay.
So that creates more uncertainty in the climate as well. Now, what kind of impact can these have? Well, one of the more drastic examples are natural disasters, which are made both more severe and more likely by climate change. So, for example, if you think of heat waves and heat extremes, if the overall global temperature is increasing, then you're getting a general shift towards warmer temperatures, and hotter days are becoming both more likely and more intense.
Yeah.
The even perhaps more extreme and long-term version of that is a drought, where you're facing both warm temperatures but also no rain.
Of course.
More heat can lead to more evaporation, so you're pumping more water from the land, but you're also increasing the water vapor in some parts, which means that when it does rain, it can really rain torrentially. It can dump a whole lot of water in one place, basically.
And this can happen on different scales. This can happen on a geographic scale where some areas will just experience a lot more evaporation while others will experience a lot more precipitation. Whereas sometimes it's just on the scale of a year that sometimes there will be very long dry spells and then all the water will come down at once.
Spot on. I think that's really important to understand. Yeah. What we're discussing are also floods, which, extreme precipitation can be caused by.
Yeah.
They can also be worsened by rising sea temperatures because you've just got more water in an area. There are also hurricanes and typhoons and cyclones, which are similar events that become more destructive due to warmer oceans.
Okay, how so?
Because you get, again, it's just more water. You get more water vapor, and that means that more water can fall in one spot. And I think warmer oceans can also impact their course and where they end up being.
Of course.
I also came across this really interesting bit of research where scientists are now able to calculate how much of the rainfall of a given hurricane, for example, is caused by global warming.
Okay.
Which I thought was fascinating. So there's this study that was done on 6 of the major hurricanes that struck the Atlantic coast of the United States in the past 20 years. So for people who are familiar with the names, those are Katrina, Irma, Maria, Harvey, Dorian, and Florence. And they were able to quantify how much extra water fell because the Earth was warming.
That's really interesting.
That's really interesting, and I think it's very powerful because they were able to show these maps of how much, what areas were flooded, for example, and then a similar map that shows what areas would have been flooded without global warming. So you have this very concrete evidence of, this area was destroyed because the Earth is warmer.
Yeah, I think it's a very good point to make that those natural disasters have happened before and they will keep happening, but it's the scale at which they happen, or the frequency probably sometimes as well, that
both
gets increased by global warming.
Exactly. So this piece of research really struck me. The last natural disaster I'd like to mention is one that I think has a lot of media coverage these days, are fires, which are made more common and more widespread because of rising temperatures, because, forests are dryers, maybe trees are dying more as well. And so that means that fires have the potential to be a lot more huge in scale.
Yes, of course.
So overall, it's been found by the Food and Agriculture Organization that the annual occurrence of disasters has tripled since the 1970s and the 1980s because of a warmer Earth.
That's very terrifying. I'm looking forward to the episode where we stop mentioning a few solutions. This is the uncomfortable truth, and we need to sit through it. But
I think this really is the uncomfortable truth.
But so you just explained very well how global warming translates into climate change. I'm curious what this means for us humans.
Yes. So that's precisely what I'm going to be discussing now. Again, it may be a fast-paced way because there's a lot to cover.
No
but
worries.
I think it's fairly easy to imagine that natural disasters and extended heat periods, less predictable rainfall, will affect the food that we're able to eat.
Of course.
Every natural disaster ruins the crop in that area, for example.
Yeah.
But also, water is going to be affected by these natural disasters.
In what way?
I'll mention 2 ways in which water quality might be affected by climate change. One, as we've mentioned, floods.
Yeah.
Floods mean that there's more water in one area, that it might overflow from riverbeds and areas where water is typically contained to areas that might be contaminated. If I think of a lot of the city streets I walk on, I wouldn't be too comfortable having my drinking water come in contact with them because they're generally not very sanitary places.
Of course.
You can get degradation of the water quality there, but also sea level rise might compromise water quality and availability as well. Because as sea level increases, it might permeate the groundwater that a lot of us rely on to drink. And if that water becomes salty, it's no longer
drinkable,
fit for us to drink at all. Yeah.
And it's also the same thing for communities that rely on coastal rivers. When the sea level increases, then the seawater starts intruding into the mainland and taking over some of the rivers, and those communities which rely on those rivers for fresh water will soon find that the water turns salty as a result of the sea level rise.
Exactly. So that becomes a threat to your access to water. Now, as a plant person, I'd like to pepper in some plant science here.
Yeah.
Because I think if I were to play the devil's advocate, I would say that, we learned in the first episode, one of the reasons global warming is happening is because we're releasing more CO2, more carbon in the atmosphere. Carbon can be perhaps grossly approximated to plants' foods. If plants have more carbon, wouldn't they grow better? Won't we be making more food?
That is a valid question. Yeah, because that's what they take up from the atmosphere to produce their nutrients.
And actually, the answer to that is yes, plants are expected to grow faster. But this still is going to be detrimental to our crop production because faster growth comes at the expense of the plant absorbing more micronutrients from the soil. And so you end up with perhaps more, corn or wheat or whatever you're growing, but it will be less nutritionally valuable. And so that's another way in which climate change and global warming are going to detrimentally impact the food that we have access to.
I had no idea about that, but that's actually quite crucial. Interesting. Thank you, Lorraine.
Now, very linked to food and water is the economy. So you can imagine that natural disasters come at a huge economic cost.
Yeah. And that cost is only expected to increase the more we wait to at least reduce our emissions.
Exactly.
So the longer we wait, the more money we'll have to spend on the consequences of those natural disasters.
Of climate, exactly. Now, to illustrate this, I've taken maybe a slightly more long-term issue we'll face, which is sea level rise, which we've mentioned in a couple episodes. And I'll just very briefly mention, why is the sea level rising? One is there's more water in the sea because of all the ice that's melting. But also, water takes up more space when it's warmer. So there's what's called thermal expansion of the ocean.
Yeah.
Now, if you think of a lot of the world's cities, a lot of the world's major cities, many of them are found either next to estuaries or on the seafront.
Yes.
So I've made a list of one major city on each continent that is potentially threatened. So you've got New York in North America, Buenos Aires in South America, Cape Town in Africa, Mumbai in Asia, Athens in Europe, and Sydney in Australia. So you can imagine that the economic impact of both having these areas not be livable, but also having to move everything, and all the economic growth that's generated within these cities is potentially threatened by something as simple as the level of the water rising. Now, linked to this, and Kiara, you had also maybe foreshadowed this earlier.
Yeah.
Climate migration is also a huge issue. It's mentioned in the IPCC as well.
Yeah.
And there is evidence that climate change is currently and will continue to drive involuntary migration. So migration that's caused by, drought and storms and floods that make people's homes no longer livable.
Yeah.
And that will drive migration. And the last point that I'd like to make as to the impact of climate change on human systems is our health. And I think this is generally quite underappreciated. In what I've heard about climate change so far, and what's known is that, for example, floods lead to an increase in waterborne diseases.
Okay.
So things like gastrointestinal infections in high, middle, and low-income countries, according to the IPCC report.
Okay.
So it doesn't matter where you are. If there's a flood, your health is at risk.
Of course. Drinkable water will get contaminated, and everyone's equal when it comes to that.
Exactly. And so I'll end with this, I feel, quite strong point that climate change is a global issue that's affecting us all personally.
Yeah.
Now, I've taken a very human-centric approach so far.
Yeah, I've noticed.
But I think it's really important to discuss the impact on non-human systems as well, because this is damage that we are triggering and that's having an impact not just on us. And so I have three main impacts on natural habitats that I want to briefly discuss. But Kiara, as an animal ecology expert, feel free to give extra detail. But one of the ways that climate change is affecting natural habitats and animals and plants is by leading to range shifts. So range is just the area in which a species is found. And because of climate change, certain habitats are either migrating or are becoming virtually non-existent. And so I think one of the most striking examples of this is polar bears, who rely on sea ice to hunt seals. They make little seal-sized holes in the ice.
Yeah.
When the seals come back up after having caught their own food, they become the polar bear's food.
It's the way of life.
Now, if there's no sea ice anymore, polar bears can't hunt seal, and this can lead to them spending more time on land, so having more interactions with humans, which can be dangerous both for the polar bears but also for us.
This is a perfect example of range shifts, and It doesn't have to happen only in the Arctic, although that's where we have the most striking examples, because that's where there's a lot of shift in the temperatures there. And of course, animals are adapted to specific temperature ranges, so they will migrate northwards to kind of keep the same temperature conditions. And this also leads to two different types of foxes meeting, the Arctic fox and the common mainland fox, Ooh. Which actually have been found to now share an ecosystem, which wasn't the case before. And our red fox is a lot more aggressive than the small Arctic fox, which usually results in the death of the Arctic fox, which is not as strong as the red fox. Those range shifts can be problematic in the way that species that haven't been in contact before will come in contact. And if they share the same food sources, then there will be competition and sometimes exclusion of one species, or even worse, the extinction of that specific species, if it didn't manage to coexist with the other.
Okay, that's very interesting. I didn't know this two fox problem. I was also going to mention extinction as the second issue that is affecting the natural world as a result of climate change. And I'll give a very direct example, I think, is that there is a tuatara reptile in New Zealand. And I know this is not the only reptile that does this, but the eggs of the tuatara will produce females only in colder temperatures.
Yes.
And so if it's warming, you get an overabundance of males.
And no females.
And then no one's breeding. And,
yeah, of course.
And the population can crash really quite fast.
Okay, that's daunting. So only slight increases in temperatures can throw off complete species in the way they reproduce and how they sustain themselves.
The last one I'll mention is, again, a slight plant example. But a lot of plants and animals and insects take cues from the temperatures and the light conditions that they're around. And this is the case, for example, for both plants and their pollinators.
Yes, absolutely.
And so you can imagine that if they don't respond to in the same way to these changing conditions, there might be a mismatch. And then some plants might not be pollinated, while some insects may miss a key source of food.
So, yeah, in a very concrete way, if a flower will start flowering earlier because of increased temperature, once the bee gets out of hibernation, there will be no flower for them to pollinate, or vice versa. And that flower, which relies on that very specific pollinator, will not be pollinated that season because the change in temperatures forced each species to adapt the best they can. And sometimes their adaptations don't overlap, which causes a mismatch and throws off entire ecosystems.
Exactly. So if I summarize part 1 of this second episode, global warming translates to climate change mostly through disturbed weather patterns. And that leads to overall more weather extremes, more natural disasters and more frequent natural disasters. This can have impacts on human societies in terms of our agriculture and the water that's available to us, in economical terms, in terms of migration.
And of course, climate change impacts wildlife, which very much relies on our ecosystems and which suffer directly from natural disasters and an increase in temperature and a different climate.
Yes, exactly. So that's a summary of the part 1. I'll hand it over to you, Kiara.
So let's move on to maybe a bit more specific case, which will be a bit more rooted into animals and ecosystems. But as you have probably figured out by now, everything is linked, and even the slightest change in ecosystems will have an impact on human communities and societies. We'll take a step closer to the ocean, which is known to have absorbed 90% of the heat emitted by rising carbon dioxide emissions. So 90% is just crazy. The ocean absorbs 90% of the heat we emit.
That's really impressive, yeah.
One of the reasons for this is because the ocean is a lot deeper than the atmosphere is thick. So it can absorb a lot more heat than the atmosphere can. And this, of course, has a lot of consequences. It induces sea level rise because a warmer ocean will expand, but also this triggers ocean acidification, meaning that the ocean gets more acid the more CO2 it absorbs. I'll get into this later because this is very important. But just remember, more CO2 means that the ocean gets more acid. So all these changes to the ocean do not only impact natural ecosystems. This also has a direct impact on us humans. I think there's around 680 million humans which live on low coastal areas. And around half the world's population, so 3.3 billion, who depend on fish for protein. So any change in the ocean's ecosystem has an impact on fish communities, has an impact on fisheries, and therefore an impact on half the world's population, which depends on fish.
Yeah, that's a lot of people at risk in a very direct manner.
Yeah, the UN has been warning us that half of the world's marine species will be on the brink of extinction by 2100. I think it's very hard to imagine, but half of this marine species will probably be on the verge of extinction in less than 100 years.
Which is crazy, given that also we know, I don't know to what extent this is true, maybe this is something for the fact check, but it's often said that we know more about outer space than what's in our sea. Have you heard this, Kiara?
Yeah, we'll need to fact check this, but this is very interesting. Yeah, knowing that 50% of something we don't even know about will disappear is very scary, because then we don't even get a chance to explore it and to research it before it's gone. And then it probably has consequences that we cannot even quantify because we didn't know what was there in the first place.
Yeah, if we haven't researched it, it's harder to protect it.
Of course.
As well.
Yeah, and just saying that today, even at 1.1% of global warming, it's been estimated that 60% of the world's marine ecosystems have already been either degraded or used unsustainably. So I can't even imagine what it would be at 1.5 degrees of warming. I do know that for 1.5 degrees of warming, between 70 and 90% of coral reefs will be destroyed.
I know that coral reefs are very susceptible to warming.
They're incredibly valuable to our planet. They're one of the most ecologically and economically valuable ecosystems for our planet. They support 25% of marine biodiversity. Wow. So many species rely on them to provide for food, shelter, but also us. There's 1 billion people who rely on it for economic purposes.
Really?
Not only through tourism, but also through sources of medicine. Also, fisheries rely on corals because that's where baby fishes grow before they're ready to venture out in the ocean. But also because, and that's something that I'm going to get into with this article, is that they provide coastal protection. They protect coasts from erosion because they're kind of like a wall that protects our land from big waves and storms and water surges.
Okay.
So this is all of this is an introduction just to tell us that ocean habitats are very useful and they're kind of our friends. The one organism I wanted to talk about more are seagrasses. They've been incredibly helpful. They've been shown to absorb up to 4 times more carbon dioxide than terrestrial forests.
Oh, wow.
Yeah.
Yeah, I feel like the Amazon rainforest has been flagged as, okay, this is a huge thing we need to protect. We want to address climate change, but seagrass.
Seagrasses are the real unknown heroes. It's been said that they can store up to 1,000 tons of carbon per hectare in the span of 2 decades. So they do that either in their biomass, in their leaves, or on the underlying soil.
Can you, Kiara, for someone who's never seen seagrass, can you describe like what it looks like, where it might grow?
I think it usually grows in bays or coastal areas, so right before the level of the land drops really deep. But I'm not really sure about this.
Because you want light, right? If you're doing photosynthesis.
So you can think of them as really tall, long grasses that grow in shallower areas near bays.
They're like forests. I've heard the term kelp forest used.
Yeah. So seagrass is, I think, another type of them, but I think it's all-encompassing. And not only do they sequester carbon, as I said, they don't only take up carbon from the atmosphere, they also improve water quality by filtering it. They also provide coastal protection against floods and storms, and this is central to the article I'm going to present.
Okay.
So that is what you need to know about seagrasses before going into this article. But it has been shown that areas covered by seagrass have gone down by up to 60% recently due to us humans who have directly removed it to build harbors, channels, marinas. Also due to fishing methods that we use that are quite destructive. One of them being trawling, where you grate the seabeds, and of course, well, the seagrass doesn't survive it. But one of the reasons why they also disappear is climate change. This is mainly due to physical stressors because of extreme weather events. And that's something that a team, I think it's a Belgian team, has been looking into in this article that I'm going to present, which is called Climate Change Mitigation by Coral Reefs and Seagrass Beds at Risk. How Global Change Compromises Coastal Ecosystem Services. So I think it's good to start by defining what an ecosystem is.
That's what I was going to say.
Because that's a word we hear all the time.
Yeah, I think it's a really key concept in ecology, and I think it makes very clear the extent to which humans rely on natural environments, and that we have everything to gain from protecting natural environments, even ones that maybe our reliance on isn't as clear or as direct.
Yes. You will find out that we rely on a lot more than just the Amazon forest, for example. So an ecosystem is a community of living organisms in a specific area. That is the dictionary definition. What does that mean? To take a very simple example, if you have a backyard at home, if you have a garden with a lot of different species, well, all those species that thrive and live in there constitute an ecosystem. So this community of organism in a specific area. So take your backyard, for example. Yes. It's an assortment of flowers, trees, sometimes animals, a few hedgehogs, who knows?
You're lucky.
Depends on where you live, of course. And now moving on to ecosystem services. What are those? Well, those are all the positive contributions of your ecosystem to human well-being in very practical ways. So for your garden, it means, I don't know, you may have an apple tree. An ecosystem service is that you get apples every autumn to harvest and to eat. But in more global, general ways, an ecosystem service, for example, is that the environment provides us with clean, fresh water to drink. That's invaluable. Bees provide us with pollination, which in turn provides us access to fruits. Those are very broad, basic concepts. The fact that plants perform photosynthesis. Well, thanks to them, we have an atmosphere which we can live in. This does not only apply to those very practical ways, but also in cultural ways. It's been accepted widely now that an ecosystem service could be that nature gives us areas for recreation, places to rest, places to be creative as well, to inspire us, to create art. So those are all the ways in which an ecosystem can provide a positive contribution to us humans.
I had come across an estimation of the economic value of ecosystem services. Were you going to discuss this, Kiara?
No. Enlighten us, please.
It's been estimated to provide us with services that are worth $125 to $145 trillion a year. So I think that gives like a scale for just how essential these are.
That's crazy. Those are all the little things that we don't really think of, but that sustain life on Earth and that we really need to value and treasure and protect. So going back to that article, it's titled How Global Change Compromises Coastal Ecosystem Services. And we mentioned a few already, but seagrasses, well, what ecosystem services do they provide based on what I've said before?
They provide protection against waves, so coastal against coastal erosion, for example.
Yeah.
They provide carbon capture.
That is true.
Do they also provide, I mean, if we're kind of comparing them to a forest, I'm assuming they're also habitats for fish and just marine life in general.
Absolutely, yes. They also do something very specific, is that they provide fishes with a sort of very unique chemical ecosystem. So because of global warming and the increase of concentration in carbon dioxide in the atmosphere, the ocean gets more acidic. How does that work? Well, oceans are a little bit of superheroes. Not only do they absorb the heat we produce, they also absorb up to a quarter of the carbon dioxide that we release.
Okay.
So it's a very natural reaction. The carbon dioxide dissolves in water, and then it forms something called carbonic acid. But this carbonic acid is not very stable, and it will soon dissociate and produce not only, but most importantly, hydrogen ions.
Okay.
So it's not really important that you know what this is, but just know that the ocean takes up carbon dioxide, and this increases the concentration in hydrogen ions. And those are quite acidic, which means that the more CO2 the ocean absorbs, the more acidic it will get.
So if we all picture ourselves as little fish, and we're just swimming around in some water, it's as if someone added a bunch of lemon juice in the water.
So of course, this is going to have an impact on the species who live there. They're going to have to adapt. But the really nice ecosystem service that those seagrass ecosystems provide is that they kind of counteract for this acidification by providing very fluctuating, very small environments where the acidity temporarily is decreased compared to the environment around.
Okay.
So this is very good for fish or small organisms who cannot really adapt to the acidification so fast and need to find places where the increase in acidification is not as strong. So those scientists wanted to quantitatively measure how all these ecosystem services were going to be impacted by sea level rise, which is one of the consequences of climate change. So they looked at one island in the Caribbean, Saint-Martin, and looked specifically at one bay there, where sea level is expected to increase by 80 centimeters. So they took this measure and they built a hydrodynamic model to see the effect of sea level rise and ecosystem degradation on the seagrass environment. So
a hydrodynamic model is...
Yes, that is a good question. A hydrodynamic model is a model, just modeling that simulates present-day flow and waves within that bay.
Okay.
And they couple that simulation with vegetation interactions and see how all these different components interact at present.
So it's something you run on a computer?
Of course. And of course, they create these equations. It's very complicated. But then they went out in the field to make sure that what they had predicted was actually observed right now. So this is the present model, and they made sure that it worked.
Okay.
And then what they wanted to investigate is what happens in the future in that bay with all that seagrass. So what is also important to say about this bay is that there's a coral reef around it, just like a protective wall, like we said before. And they looked at 3 scenarios for the future of that coral reef. So in one scenario, the coral reef is able to keep up with the sea level rise and grow in height.
Okay.
As fast as the sea level rises. In the second scenario, the corals survive, but they stay the same height. And in their third scenario, the corals just disappear because they die because of global warming.
Okay.
So those are their 3 parameters in their models. But at the same time, they simulate seagrass coverage in that bay. So there's only 2 scenarios there. It's either present or it's absent.
Okay.
And so they take all those different parameters of that bay, coupled with the model of waves and tides that they already built based on present conditions, and they look at how the seagrass coverage affects the acidity variability of the ocean, the grain size of the sediment in that bay, so of the sand, you could say, and closely linked, they look at the erosion of the coast in all of those different types of scenarios.
So if I summarize, they're looking at what the impact on erosion, sand grain size, acidity, and maybe coral reef health is, depending on whether or not you have seagrasses in that environment.
It's almost everything correct, except for the coral reefs. The coral reefs are just a variable. They're looking at 3 different scenarios with 3 different types of coral ecosystems.
A more accurate way would be that they're looking at grain size, erosion, and acidification, depending on whether or not you have seagrass or not, and depending on your coral reef health.
Mm-hmm.
Yeah, okay.
Yeah, so the first finding that they have is that an increase in sea level means that there's also an increase in hydrodynamic forces. Mm-hmm. What does that mean? That just means that the ecosystems there, or even the bottom layer, will be subject to more forces because there will be more water flowing in and out of the bay. The first result of this is that the seafloor will be made up of larger grain sizes. Because usually, when there's more forces, there will be more destruction of those grain particles, and all the smaller bits will flow away more easily, and all that's going to be left behind are those bigger, coarser grains.
Okay.
Which leads to, of course, an increasingly unstable seafloor.
Oh, yes.
Which is more vulnerable to erosion.
Is it a possibility as well that you get more erosion if the particle sizes are bigger? As in, do they have potentially more force to kind of carve out?
Yes. They also looked at the impact of the loss of a coral reef on this ecosystem, and they found that it's not going to make a big of a difference if it grows enough to keep up with sea level rise. Okay. However, if the coral reef just dies because of other factors, then the bay will be subject to a lot more shear stress, a lot more forces, water forces rubbing against this. However, this doesn't have that big of an impact, especially in shallow areas, which shallow areas usually are exposed to a lot more stress, a lot more forces from waves.
Okay.
So sea level rise will actually increase the sea level on those areas, shallow areas, and make them a bit more calmer and better for seagrasses to grow, because the increase in sea level will make these ecosystems a bit more peaceful.
Yeah, that makes sense. If the wave is only at the surface, or when it crashes, it disturbs the surface layer. If you've got like a bottom layer that's calmer, as you say, then I can see how seagrasses might like it better.
Yeah, so while coral reef has a little bit of an impact on the ecosystem of the bay, the real finding of this article is that the loss of seagrass is going to have the strongest consequences in the bay ecosystem.
So even more important than corals?
In that case, yes.
Okay.
Because when they disappear, when seagrass disappears, the sediment that they were growing on becomes more unstable.
Yes.
So at the same time, more hydrodynamic forces increases the instability of the ground. But when there's no seagrasses, this gets intensified. And I think they could calculate that the median sediment grain size increased by 7%, which doesn't tell you a lot, but it has an incredible impact.
The grain sizes are getting bigger.
Yes. Yeah. And at the same time, loss of that seagrass also means that there's a loss of that very unique fluctuating chemical habitat. Because, of course, the seagrass is used to serve as a safe harbor for all those species which had to hide from that ocean acidification. So this entire study found that the loss of seagrasses would be dramatic, both on the level of coast stability and erosion, because the sediments would become a lot more coarser, unstable, and this would leave the coastline a lot more vulnerable to erosion.
Yes.
And at the same time, you have the loss of such a specific ecosystem for very valuable animals.
I think one of the takeaways that I'm having from this episode is that so many things are linked, because a lot of the sort of impacts of climate change that I mentioned were linked, a lot of the natural disasters are linked, but also here, you lose fish, you lose a source of food, you lose an economic sector.
Of course. That was going to be my next point, because now I just talked about the effect on that ecosystem. But of course, the loss of seagrass is going to increase the erosion of the coast. This is going to have an impact on the communities that live there. There's, as I said, 680 million people living in very low coastal areas. So this is one way that this could impact human communities, but also the fact that you lose a chemical habitat for a lot of fishes. A lot of fisheries rely on those habitats. They're fish nurseries where the fish spend the early months of their lives. And if you lose that ecosystem, then of course there's going to be less fish that can develop to an adult stage and can be used as food source to humans.
Of course.
So that was all from this article. I think it was a very good way to see how one effect of global warming and climate change, being sea level rise, can affect such a diversity of organisms, from humans to marine species.
Yeah, something that the article has made very clear is how dependent we are in so many direct but also very indirect ways on ecosystems.
But so this was quite a stern episode where we had to face the facts and go through all the impacts that this is going to have on our planet, how it affects virtually every corner of the planet in very different ways, of course, but very dramatic ways that
And as usual, we like to leave you with a resource you can go and check out in your own time. And as I've mentioned, during my IPCC deep dive, I found this really cool AI tool that's built on the IPCC. It's called Chat Climate. If you type Chat Climate AI into your web server, you'll find it. And you can ask it any kind of climate-related question, and it will give you an answer that's based on the IPCC, which I think is quite interesting. So this AI can really make it a lot more accessible. So I encourage, if you have any outstanding questions after this episode, please go ask them to Chat Climate AI or in our comment section.
I think I'll do that once we finish recording. I think it's great that there's such a tool.
Yes.
But as always, if you have any questions or suggestions, please comment or send us an email at smalltalk.bigissue@gmail.com. You'll be hearing from us in 2 weeks for the next episode, which will be a continuation of this one and is going to investigate whether climate change is going to be fair or not. So stay tuned and talk to you soon.
See you next time.
We fact-checked this episode and wanted to clarify a few things. Lorraine said that the IPCC releases reports every 7 to 8 years. Actually, the releases are usually 5 to 7 years apart. As an example of range shifts, I mentioned the tooth fox example, where one species invades the other's habitat. I wasn't sure about the species while recording and named it inland fox. It is actually the red fox, which competes with the Arctic fox. Earlier in the episode, I also said that I thought 680 million people live in very low coastal areas. I'd like to confirm this. Lorraine said that we know more about outer space than our oceans, or was questioning it. So after some research, we found out that we know the surfaces of the solar system better than our ocean bottoms. But it does not mean that we know more about outer space than our oceans. You'll find a lot of sources telling you a lot of different things, and this is simply due to the fact that ocean exploration and space exploration are really different and therefore difficult to compare. It's also usually used as an image to show how little we know of something that's so close to us, like the ocean. I also said that kelp is some sort of seagrass. I must apologize because this is not true. Kelp is an algae, while seagrass is a flowering plant, and if you look up pictures of them, you'll see how different they are. That's it for this week. See you next time.